Okay folks, buckle up. Tonight on the Mysteria Archive, we're heading beneath CERN to explore the quantum portal problem. What happens when reality is pushed so hard it starts to feel like there's a doorway. Get ready for a wild ride. Something feels off. Not broken, not wrong, just slightly misaligned. Like reality itself has a tolerance level, and lately we've been leaning right up against it. People talk about reality glitches, shared memories that don't line up. Moments that feel edited. Not enough to panic over, just enough to notice. And here's the thing. If reality were ever going to show its seams, it wouldn't happen in a haunted house or a sci-fi movie. It would happen in a lab. A very clean one, with clipboards. Deep beneath the border of Switzerland and France, there's a machine that pushes matter harder than anything humanity has ever built, forcing reality into conditions it almost never experiences. This place is CERN, and this is the quantum portal problem. What happens when reality is pushed so far that its rules stop agreeing, and something that feels like a doorway starts to emerge. Before we go any further, let's slow this down. When people hear CERN and portals in the same sentence, they picture something dramatic, a doorway, a rupture, a moment you'd notice. But what actually unsettles physicists is something quieter. CERN is the one place on Earth where we don't just observe reality, we stress test it. Particles smashed together at energies that haven't existed since the early universe. Not to open anything intentionally, but to see how reality behaves when pushed into unfamiliar regimes. And physics has taught us something uncomfortable. When you push nature hard enough, it doesn't always fail loudly. Sometimes it responds in ways that are subtle, structural, and easy to miss, especially if you're looking for spectacle. And that's where the quantum portal problem really begins. How CERN creates portal conditions. Let's ground this, but not too comfortably. CERN isn't a secret military base. It's something quieter than that, and arguably stranger. It's a place built to push reality into conditions it no longer visits on its own. At the center of CERN is the Large Hadron Collider, LHC, a vast circular tunnel buried underground, where particles are accelerated to just below the speed of light and smashed together with extraordinary precision. These collisions aren't about destruction, they're about pressure. Enough energy to briefly recreate conditions that last existed fractions of a second after the Big Bang. And when you do that, something interesting happens. Hidden rules start to surface, new particles appear, old assumptions stop working. Reality doesn't behave wrong, it behaves deeper than expected. And this is how the Higgs boson was found, not by accident, but by forcing nature into extreme corners and watching how it responded. CERN studies fields, forces, and symmetries, the invisible framework everything rests on. But to map a framework, you have to approach its limits. And when experiments reach energies the universe itself rarely uses anymore, you're no longer just observing reality. You're creating boundary conditions, places where different descriptions of reality have to coexist. Physicists are confident that the LHC is safe, but safety doesn't mean simplicity. It means nothing catastrophic happens, not that everything that happens is fully intuitive. At these scales, intuition fails, math takes over. And this shouldn't happen quietly becomes, this happens all the time, just not where humans normally look. Now, this is where the quantum portal problem actually starts to take shape. CERN operates in territory we don't experience anywhere else. We recreate conditions from the early universe and assume reality will behave the way our equations predict. So far, it has, at least, as far as we can tell. But these experiments don't just test particles, they test assumptions about space, about stability, about how much pressure reality can take before different rules start overlapping in ways that feel unfamiliar. And nothing dramatic happens, nothing obvious, but some things don't announce themselves loudly. They only appear when you stop asking politely and start pushing. When reality has more than one state. Here's where things start to feel quietly unsettling. Modern physics suggests that the universe might not be sitting in its most stable state. Not broken, not collapsing, just temporary. There's a concept called false vacuum decay. Think of the universe like a ball resting on a shallow dip on a hillside. It looks stable, it feels stable. It's been there for billions of years, but somewhere below it, there may be a deeper valley, a more stable state that reality hasn't yet reached. If the universe ever slipped into that lower state, the transition wouldn't look like an explosion or a collapse. It would be instant, silent, and undetectable until it was already over. Now, the laws of physics themselves would change. Particles would behave differently, chemistry might not work, stars wouldn't form. There would be no warning, no flash in the sky, no moment to observe. And that's why physicists talk about it. Not because they think it's likely, but because it's possible in theory. And physics is a discipline that takes even uncomfortable possibilities seriously. Now, here's the important part. CERN didn't invent this idea. The theory comes from quantum field models of the universe itself. CERN just happens to be one of the few places where we can test physics at energies high enough to even talk about these questions with a straight face. Most physicists believe the risk is effectively zero. The universe has been smashing particles together naturally for billions of years at energies far higher than anything humans can produce. Still, the idea lingers, not as fear, as humility. Reality might not be permanent, just very, very long-lived. Yeah, this is the part where everyone's brain goes, cool, wait, what? Now, to be clear, physicists aren't lying awake worried CERN will end the universe on a Tuesday afternoon, maybe by Thursday. Now, if false vacuum decay were easy, cosmic rays would have done the job ages ago. So no, this isn't something experts expect to happen. But, and this is the part that sticks with people, unlikely doesn't mean impossible. We like thinking the universe is solid, locked in, guaranteed. Turns out, it might be more of a long-lived running software version, stable, reliable, but still a version, not a permanent promise. When experiments become irreversible. So, if these ideas aren't new, why does CERN keep showing up at the center of the anxiety? Because CERN is where the theory stops being hypothetical and starts being physical. It's one thing to explore exotic physics on paper. It's another to build a machine that recreates conditions the universe itself hasn't needed since its opening moments. CERN didn't invent the possibilities people worry about. Those come from the equations. But it does something rare. It turns abstract limits into real experiments. And this is where the quantum portal problem becomes uncomfortable. Now, physicists talk in probabilities, confidence intervals, phrases like vanishingly small. To them, that's precision. To everyone else, not impossible doesn't feel reassuring, especially when the outcome, however unlikely, would be irreversible. You can't rewind a vacuum transition. You can't undo universe-scale experiments. The discomfort isn't really about danger. It's about finality, about crossing boundaries you can't step back over once they've been tested. That's why public concern keeps resurfacing. Even after safety reviews, transparency, and decades of operation, it's not distrust in scientists, it's discomfort with the idea that someone somewhere is now capable of pushing reality into regimes where the consequences, whatever they are, can't be taken back. Physicists acknowledge this tension. CERN's work is debated, reviewed, and scrutinized openly. No one there treats these questions lightly, but transparency doesn't erase unease. Because at a certain point, the fear isn't that reality will break, it's that we're no longer just observers of the universe. We're participants in the experiments that probe its limits. And once you cross that line, the universe stops feeling like a backdrop and starts feeling like a system under test. Now, this is where people start talking past each other. Scientists hear low probability and think manageable. Everyone else hears low probability and thinks, why is this even something we're allowed to test? It's like flying. Statistically safe. Emotionally, you're still strapped to a chair going hundreds of miles an hour with no undo button. CERN triggers that same feeling. Not fear of scientists, fear of irreversibility. And honestly, that's a very human reaction. Risk is easier to accept when the consequences aren't literally everything. When observation becomes a portal event. At the quantum level, reality behaves in ways that feel deeply counterintuitive. Particles don't have definite properties until they're measured. They exist as probabilities. Possibilities stacked on top of each other, and it's only when observation happens that one outcome locks in. That's not philosophy, that's how the math works. One way physicists interpret this is called the many worlds interpretation. It suggests that when a quantum event resolves, reality doesn't select just one outcome. Instead, all possible outcomes continue. branching into separate, non-communicating versions of reality. Most physicists don't treat this as sci-fi. It's a bookkeeping framework, a way to keep the equations consistent when collapse becomes mathematically messy. But here's where the quantum portal problem becomes physical. The Large Hadron Collider doesn't observe one particle at a time. It forces outcomes constantly, trillions of collisions, measurements happening relentlessly. A machine designed to push probability into decision over and over again. At that scale, observation is no longer passive, it becomes intervention. No one at CERN believes they're opening doorways between worlds, but they are operating in a regime where quantum events are being resolved deliberately, repeatedly, and at a scale unmatched anywhere else on Earth. If reality branches when observed, even quietly, then CERN is one of the few places where branching would be happening continuously. Not as a rupture, not as a glowing doorway, but as physics doing exactly what its own rules allow, which leads to an uncomfortable implication. If observation creates outcomes, and outcomes define reality, then reality may not be as singular as it feels. It may be layered, held together by consistency rather than certainty. At human scales, nothing feels different, but at the edges, something fundamental may be happening without fanfare. Now, this is usually where people imagine universes popping into existence like bubble wrap, and that's not how physicists think about it. Many worlds isn't about timelines you can visit, it's about math refusing to collapse neatly. But it does mess with our intuition. We like the idea that observing something is harmless, that we're just watching. Quantum mechanics says otherwise. Even looking counts. And when you build a machine that looks at reality trillions of times a second, you're not just observing anymore. You're forcing decisions, calmly, professionally, in lab coats. When reality feels out of sync. Now, let's bring this down from particle accelerators to everyday life. All over the world, people report shared memory discrepancies, details remembered clearly, but incorrectly, logos that feel wrong, events that seem edited after the fact. This cluster of experiences is often called the Mandela effect. There's no scientific evidence that reality itself has changed. Memory is famously unreliable, and psychology offers strong explanations for how collective false memories can form. And yet, the effect lingers, not because of proof, but because of pattern. Now, the odd thing isn't just that people remember things differently, it's how similar the memories are, how confident people feel about them, and how often the discrepancy is noticed emotionally before it's analysed logically. Memory seems to be the first thing that reacts when something feels off. If the quantum portal problem has a human-scale footprint, not a rupture, not a doorway, just a boundary quietly crossed, this is likely what it would feel like from the inside. Not an alarm, not a headline, just confusion, déjà vu, a sense that something isn't quite where you left it. If reality ever adjusted itself at a deep level, matter would settle into the new rules instantly, but minds might lag behind, carrying expectations formed under slightly different conditions. That's speculation, not evidence. But it's the kind of speculation that persists because it mirrors the experience itself, subtle, unannounced, mundane. If reality changes, it probably doesn't stop to explain itself. It just keeps going. And when people notice, the only tool they have is memory, which makes the entire conversation slippery, frustrating, and impossible to settle cleanly. Because you can't prove a glitch if the system updates smoothly. You can only feel that something isn't quite where you left it. It's worth slowing down here. The Mandela effect gets linked to CERN a lot, but there's no direct evidence tying memory shifts to particle experiments. What is clear is how people describe the experience, not analytically, emotionally. They don't say, "I misremembered," they say something feels off. And if reality ever did change in a subtle way, not enough to break physics, just enough to shift expectations, that's probably how it would show up. Not with alarms, not with announcements, just as a quiet mismatch between what you expect and what you see. Not proof, just unresolved discomfort. What a quantum portal actually is. This is where the word portal enters the conversation, and where it usually gets misunderstood. Physicists don't use the word. They talk about boundaries, phase transitions, limits where one set of rules gives way to another. But to the human brain, boundaries don't feel abstract. They feel like doorways. In physics, boundaries appear everywhere. between solid and liquid, between classical and quantum behavior, between one energy state and another. And at those boundaries, behavior changes, not because something travels somewhere else, but because the rules stop agreeing. That's where the quantum portal idea actually comes from. When people speculate about CERN opening a portal, what they're often responding to isn't a doorway through space. It's a mismatch between expectation and behavior, a place where outcomes don't line up with intuition. At extreme energies, like those inside the Large Hadron Collider, particles briefly occupy regimes we rarely encounter, conditions closer to the early universe, environments where fields dominate over matter, where familiar rules still apply but feel stretched. If anything were to cross between states here, it wouldn't be objects or people, it would be information, correlations, statistical relationships that resolve correctly but feel wrong narratively. That's the earned version of a quantum portal. Not somewhere you go, but somewhere the accounting gets strange. A seam between descriptions, a place where reality still functions, but our language starts to fail. If portals exist in physics at all, they wouldn't be glowing circles. They'd be quiet disagreements between models, places where everything works, just not the way we expect it to. And CERN is one of the few places on Earth where we deliberately push reality into those disagreements. And this is the part where people really want a sci-fi visual, and I get it. Doorways are easier to picture than equations. But what's unsettling is that the real version is subtler. A portal defined as where rules stop agreeing is something physics deals with constantly. Phase changes, regime shifts, boundaries where descriptions overlap but don't quite line up. And we don't call those portals because it sounds cinematic. But the experience, that sense of crossing into unfamiliar territory, it's real. And if something feels like a doorway, that might not mean there is one. It might mean our intuition has reached the edge of where it still works. Why portal language won't go away. Even after all the explanations, the symbolism refuses to disappear. Look at how CERN talks about its work. Gates, thresholds, frontiers, windows into the early universe. Even the word collider implies crossing paths. Scientists rely on metaphor constantly. Not to mislead, but because language needs handles. And when humans approach the edge of what they understand, they reach for the oldest ones. Doors, gates, veils. CERN's campus art reflects this too. Playful, ironic, sometimes misunderstood. Sculptures that look mythic. Imagery that invites projection. Not because CERN believes in portals, but because humans instinctively frame boundaries as entrances. Every civilization has done this. Caves were gateways to the underworld. Horizons were the edges of the world. The sky was a dome. Atoms were once invisible because language couldn't imagine anything smaller. Now we're pressing against the deepest structure of reality itself, and the metaphors have come back around. Portals here aren't a scientific claim, they're a psychological response. They appear when people sense they're standing at a threshold, unsure whether the next step leads to discovery or something irreversible. CERN didn't invent that feeling, it inherited it. When you push against the foundations of existence, people don't narrate it like a spreadsheet. They narrate it like a story. Heroes, risks, doors you shouldn't open, knowledge you can't unsee. That doesn't mean the story is literally true, but it does mean the metaphor matters. Because when humanity reaches a boundary, we don't say we're refining models, we say we're opening something. And maybe that's the real portal. Not in the ground beneath Geneva, but in the way our understanding keeps stepping into places our intuition hasn't caught up to yet. This section is less about CERN than it is about us. Humans are terrible at sitting with boundaries. We want doors, we want moments, we want a clear before and after. Scientists use metaphors because they have to, and once those metaphors escape the lab, they take on a life of their own. Add in art, symbols, and the internet, and suddenly language hardens into belief. That doesn't mean anyone is hiding anything. It means we're trying to describe experiences our intuition wasn't built for. We want an entrance. Reality gives us math. And when those two don't line up, the word portal fills the gap. Reality under stress. Now, let's put all of this together with one final lens. Not as belief, not as a claim, but as a way to test our assumptions, the simulation hypothesis. Now, not in the sense of a video game or a digital prison, but as a thought experiment many physicists and philosophers use to ask a simple question. What would reality look like if it were fundamentally an information process? In that framing, extreme experiments wouldn't break reality, they would stress it. Just like pushing a graphics engine reveals rendering limits or overloading a server exposes bottlenecks, probing reality at its deepest levels might expose seams. Not holes, not crashes, artifacts. In this view, glitches wouldn't be failures, they would be edge cases, places where the system prioritizes stability over perfect consistency. And portals in this sense wouldn't be doors you step through, they'd be access mismatches, moments where different layers of description don't line up cleanly, where what we expect to see and what reality delivers aren't identical. Notice something important: nothing ever catastrophically breaks. No runaway reactions, no reality-ending events, no violations that propagate uncontrollably. Instead, everything degrades gracefully. The math holds, the universe continues, anomalies remain subtle, statistical, easy to dismiss. That's exactly what you'd expect from a system designed to remain stable under stress. This doesn't mean we live in a simulation, but it does suggest something quietly unsettling. When we push reality to its limits, we don't see chaos, we see restraint. And whether that restraint comes from fundamental physics, emergent order, or something deeper we don't yet understand, one thing is clear. CERN isn't testing the universe to destruction, it's testing how reality responds when it's pressed. And so far, reality responds by holding together. A simulation talk always makes people tense, so let's be precise. This isn't about living in the Matrix. It's about a framing tool, a way of asking what reality would look like if it had built-in limits and self-correction. And what's interesting is that what we observe fits the pattern uncomfortably well. Things bend, they don't snap. Glitches don't spread, they dissolve into statistics. That can feel comforting or deeply unsettling, because it suggests reality isn't fragile, it's tolerant. And when something is tolerant, it can absorb a lot, without ever telling you where the actual limits are. What this does and doesn't mean. So, let's draw some careful lines. There's no evidence that CERN has opened a literal doorway through space, or that timelines are colliding, or that reality has been damaged in any obvious way. No experiment has shown violations of known physics beyond what existing theory allows. Everything still functions. What unsettles people isn't that physics is broken, it's that physics is incomplete. We don't know where the true limits are. We don't know whether reality has a final layer or just deeper descriptions stacked beneath one another. We don't know whether observation is fundamental or simply a useful way to talk about interactions we don't yet fully understand. And that uncertainty creates space for metaphors, for portals, for glitches, for stories that try to give shape to what hasn't settled into language yet. Physicists like Max Tegmark are careful about this distinction. Speculation is valuable, but it isn't evidence. Thought experiments explore possibilities, not truth. Confusing the two is where narratives harden too quickly. Still, the discomfort doesn't disappear. Because for the first time in history, humanity isn't just observing the universe, we're deliberately testing it at scales that matter. Not recklessly, not maliciously, but with curiosity. And curiosity doesn't guarantee comfort. The unease around CERN isn't really about portals or black holes or the universe ending tomorrow. It's about touching something fundamental and not knowing in advance what it will feel like to touch back. That's not fear of destruction, it's the unease of discovery. This is a grounding moment, but grounding doesn't mean closing the case. CERN isn't a secret cabal, and physicists aren't pretending to know more than they do. Reality still follows rules, but those rules aren't finished, and we can feel the edges of that. Humans like knowing where the boundary is. Right now, we're finding it by feel, slowly, carefully, without a map. That's uncomfortable, but it's also how every major expansion of understanding has begun. The takeaway isn't fear. It's humility, the kind that comes from realizing we're smart enough to ask deep questions and honest enough to admit we don't yet know all the answers. Where reality starts to bend. For most of human history, reality was something we stood inside and accepted. We measured it, we named it, we argued about it, but we never truly tested it. That part is new. For the first time, we're not just watching the universe unfold, we're pressing on it, asking it questions it can't dodge, pushing it into conditions it rarely visits. And when we do, reality doesn't shatter, it flexes. And the idea of portals keeps resurfacing, not because someone opened a doorway, but because we're finally close enough to the edges that the metaphors change and rules stop lining up cleanly. When explanations blur, when certainty thins out, the human mind reaches for doors, thresholds, gates, openings. But maybe that isn't fear talking, maybe it's recognition. If reality has boundaries, places where its rules overlap, hesitate, or stop agreeing, then someone was always going to touch them. Not recklessly, not maliciously, just curiously. CERN isn't a villain in this story, and it isn't a hero either. It's a flashlight in a very dark room, sweeping across structures we didn't know were there. And every once in a while, the beam catches something that doesn't quite look solid. A bend, a seam, a place where the rules hesitate. Not a portal you can walk through, but the quantum portal problem made visible. A reminder that reality is deeper, stranger, and less settled than it looks. So, if things sometimes feel off, if the universe feels stranger than it used to, if certainty feels thinner than it did a generation ago, that might not mean reality is breaking. It might mean we're finally close enough to see where it bends. Now, I like this ending because it doesn't tell you what to think. There's no monster, no hidden switch, no doorway opening under Switzerland, just the realization that we're not passive observers anymore, we're participants. And that's uncomfortable, but it's also incredible. The universe never promised us comfort, it promised us consistency, and so far, it's kept that promise, even when we push it hard. If reality has edges, we were always going to find them eventually. CERN just happens to be where we're poking hardest, and that feels less like a warning and more like a milestone. Thank you for watching, and I hope you enjoyed this one. And if so, why not check this one out on screen at the end? And now, all my episodes are available as Mysteria Archive podcast, which you can listen to through the YouTube Music app, which is free for podcasts, no subscription required. Happy listening. And if you'd like to support the channel further, I've just launched a Patreon site and YouTube memberships where you can get proper community chat and exclusive content on Mondays, link in the description below. As always, don't forget to like, share and subscribe. It really helps out the channel and I'd really appreciate it. Also, if you subscribe, please hit the bell icon and select all. It's the only way to be sure you'll get notified of my new videos because of the way YouTube now works. And let me know in the comments below videos you would like to see next time. Okay, my friends, be safe, and until next time, stay curious.